Now let's take a look further. Number 7. Solve the following system by any appropriate means, or by an appropriate method, as opposed to, the way Chuck Norris deals with problems, which is he stares them down until they give him the answers. Okay, now, here they gave you x times y is equal to 8, and y is equal to x minus 2. What I would go on ahead and do is I would clean this up just a little bit and get y by itself in the first equation. To get y by itself in the first equation, you divide by x, so y is equal to 8 over x. Now, the most fundamental idea of solving a system in this case is to understand that this y, which is equal to x minus 2, is equal to this y, which is equal to 8 over x. That way, you're really only solving for one unknown. So you have, alright, y is equal to x minus 2, y is equal to 8 over x. By virtue of the transitive property of real numbers, you just say 8 over x is equal to x minus 2. At this point, we need to clear the denominators by multiplying by the one denominator that we've got. So we'll multiply both the left and the right-hand side by x. So now we've got 8 is equal to x times x minus 2, or x squared minus 2x. I see that this is a quadratic because I have a second degree term. To solve a quadratic, I will get all of my terms on one side, setting it equal to 0. And so to do that, I would subtract 8 from both sides. And so now you're left with, and I'm going to draw a little line here to know that we're going to keep going. You are now left with x squared minus 2x minus 8 is equal to 0. Now you could solve it by using the quadratic formula, or you could solve it by completing the square, which is basically one is a fundamental extension of the other. I would have preferred to actually solve this by completing the square, and so in this case the subtraction of 8 was redundant. I would have said, okay, x squared minus 2x equals negative 8, that's what we had previous, or positive 8, that's what we had previously. If I was going to complete the square, I would take half of this middle term and then square it. Well, half of 2 is 1, and so 1 squared is 1, so I'm going to add 1 here and add 1 here. So now that leaves me with x minus 1 quantity squared is equal to 9. I would then take the square root of both sides, and so that gives me x minus 1 is equal to plus or minus 3. Because remember that square roots have two solutions. And so your final solution is that x is equal to 1 plus or minus 3. Well, 1 plus 3 is a positive 4, and 1 minus 3 is a negative 2. Now, since I already know I have two solutions, that is immediately eliminates C and D. We have two solutions. Now, just to double check that those values for x are valid, you simply go back to your calculator and you just say, okay, y is 8 divided by x, and y is equal to x minus 2, which you could have done the first time, but I like showing steps. And see, here you have your point, here you have your rational function, and you have your points of intersection. Lo and behold, where x is equal to 4, y is equal to positive 2, and where x is equal to negative 4, or sorry, trace negative 2, that's our other point of intersection at negative 4. So, our correct response was B. Now, number 8, a lot of people skipped it needlessly so. The answer is kind of staring you right in the face. It says the length of a rectangle is 4 inches longer than the width. The area is 96 square inches. In solving the problem, Tara factors the resulting equation and gives negative 12 and 8 as answers. Why is this a reasonable solution? Why or why not? Well, first of all, it's not reasonable because there is no way you can have a negative length in a physical universe. And so the fact that she has a negative solution makes it unreasonable. And so if you mentioned anything about it being negative, negative solutions are not valid. I gave you the point. That was actually the easiest 7 to 10 points some of you ever missed. Okay, now number 9 was just a little bit trickier. Now this relied on you understanding how inequalities work. So let's see if we can take a look at what this means. So we have a quadratic and a linear, as we've done before. So you have x squared plus x minus 6 and x plus 3. Now, the 84 doesn't handle inequalities very well, and especially where they come together. This is greater than or equal to, which means we're looking for things that are above the quadratic and below the line. So here we have our quadratic, here we have our line, and we're looking for stuff that's in the middle. And so the easy way for us to do this is to go on ahead and see where things are. Well, if I go to where x is equal to 4, 1, 2, 3, 4, I am outside of this little zone here, which is where the two things come together. So A is clearly and obviously false. Now if I go again, negative 6, that's way over here, that is well outside this small zone of intersection that is above the parabola and below the line. Both of these have to be true. 0, 6 is too high. It is well above the line. And so the only point that really works is where x is equal to 1 and y is equal to 3. It's inside the zone, well defined. Okay. For number 10, it says, which system of equations best describes the graph? Well, here you have a linear equation and you have a quadratic equation. You have a quadratic equation where the constant is 2. That doesn't help you because actually in all of these quadratic equations the constant is 2. We know the constant is 2 because that's the y-intercept. Now, really the thing that is going to let you know what it is you also know that because insiders lie, this has a positive middle term. Because we know that we write it as, okay, y is equal to x minus h quantity squared plus k. We know when we do the binomial expansion that this is some kind of, this is about x minus 3 halves squared plus a k that's going to be, we could just say negative 1/4. This is all approximation. But we know it's positive because we're moving to the left and insiders lie. And we know when we do the binomial expansion, the middle term of the binomial expansion will have the same sign. So we know this has to be positive, which means we can immediately eliminate D from consideration and C. So it's either going to be A or B. Now, here's where life gets a little bit more fun. We know that the y-intercept is 3 on this line. And we also know that we have a slope. We can find our second point here. We have a slope where we go up 1 and over 2. So we know that our slope is 1/2. This is where that little neat trick, now that doesn't help us too much because our equation here, our linear equations are both in standard form. But this is the part where that trick that if I'm given a standard form equation, ax plus by is equal to c, and I remember that my slope is negative a over b, well, that comes in really handy. Now, I know that the slope was 2 over 1, not 1 over 2. Slope is 2 over 1. Now I know that my slope is 2 over 1. So both A and B have a coefficient of 2 and a coefficient of 1. But I also know there's a sign change here, and I know this is positive. So the only way I'm going to get a sign change here is if one of those coefficients is negative. And so the correct response is B. And so you use the slope of the line, you use your understanding of a standard form equation to get the linear equation. You use your understanding of the fact that insiders lie to get that you have a positive middle term, and that's how you eliminate the other choices.